This is a video from the Exam 4 review. Let's take a look at problem 18. It's the integral of sine squared x times cosine squared x dx. Remember that sine squared x can be written as 1/2 times 1 minus cosine 2x. Cosine squared x can be written as 1/2 times 1 plus cosine 2x. So this is equal to the integral of 1/2 times 1 minus cosine 2x times 1/2 times 1 plus cosine 2x dx. But 1/2 times 1/2 is 1/4. So this is equal to 1/4 the integral of 1 minus cosine 2x times 1 plus cosine 2x dx. This is equal to 1/4 the integral of 1 minus cosine squared of 2x. But 1 minus cosine squared of 2x is equal to sine squared of 2x. So this is 1/4 the integral of sine squared of 2x dx. Now, let's recall something. Sine squared of x is 1/2 of 1 minus cosine 2x. If I replace x with 2x, I get sine squared of 2x is 1/2 of 1 minus cosine of 2 times 2x. But this is 1/2 of 1 minus cosine 4x. And so this is 1/4 the integral of 1/2 of 1 minus cosine 4x dx. 1/4 times 1/2 is 1/8. So this is 1/8 the integral of 1 minus cosine 4x dx. Now we're ready to make a substitution. I'm going to let u equal 4x. du is 4 dx. And dx is 1/4 du. So this is equal to 1/8 times 1/4 the integral of 1 minus, and then it's cosine of u du. One-eighth times 1/4 is 1/32. So this is 1/32 times u minus sine of u plus c. But u is equal to 4x. So this is 1/32 times 4x minus sine of 4x plus c. If I distribute the 1/32 inside, we get 1/8 x minus 1/32 sine of 4x plus c. And that's how we do problem number 18. And if we take a look at problem number 19, on problem 19, we have the integral from -1 to 1 of sine of x divided by 1 plus x squared dx. Okay, here's how this one works. Let f of x equal sine x divided by 1 plus x squared. If I replace x with negative x, I get f of negative x is sine of negative x divided by 1 plus negative x squared. Sine is an odd function, okay? And so I can write this as negative sine of x divided by 1 plus x squared. And I'm going to pull that negative out in front of the fraction. And so if you notice, f of negative x is negative sine x divided by 1 plus x squared. Remember, if I take a negative value and square it, I get something positive, right? And so this is equal to negative f of x. But what that tells me is that f is odd. And you're integrating from negative 1 to 1, an odd function. And so the answer to this is 0. That was the idea for that problem. And if we take a look at problem number 20. So on problem 20, we have the integral from, and it's negative pi over 4 to pi over 4 of, and then it's t to the 4th tangent t divided by 2 plus cosine t dt. Now, for the same reasoning as number 19, if I let f of t equal t to the 4th tangent t divided by 2 plus cosine t. Now, I claim f is an odd function, right? If I take f of negative t, this is negative t to the 4th tangent of negative t divided by 2 plus cosine of negative t. So this is t to the 4th times negative tangent t divided by 2 plus cosine t. Remember, cosine's an even function. Tangent is an odd function. Now, I could pull that negative out in front, and you get f of negative t is negative t to the 4th tangent t divided by 2 plus cosine t. And that's negative f of t. So this tells me f is odd. And so the correct answer here, notice you're going from negative pi over 4 to pi over 4. So you're going from negative pi over 4 to the opposite of negative pi over 4. And the answer is 0. And you're done immediately. 21. On 21, we have the following function. So we have capital F of x is the integral from 0 to x of t squared divided by 1 plus t cubed dt. And I want f prime of x. So what do we do here? In the integrand is t squared over 1 plus t cubed. I'm going to replace t with that upper limit of x. And when I do, I get x squared over 1 plus x cubed. And immediately, that's the derivative of capital F. 22. Suppose I have the integral, or we'll call it capital F. We'll call it capital F of x again, though. So capital F of x is the integral from x to 1 of the square root of t plus sine of t dt. Now, I want the variable limit to be the upper one. And so I'm going to take negative the integral from 1 to x of the square root of t plus sine of t dt. And so, therefore, I'm all set. Capital F prime of x is negative the square root of x plus sine of x. And that's how we do problem number 22. Let's take a look at 23. On 23, we have g of x is the integral from 0 up to x squared of cosine of t squared dt. Now, when I want the derivative here, I apply the chain rule. So in the integrand cosine of t squared, I'm still going to replace t with that upper limit of x squared. So I get cosine of x squared raised to the second, but I have to take that answer and multiply by the derivative of that upper limit with respect to x. So in other words, I'm going to multiply by the derivative of x squared with respect to x. And so this is 2x cosine of x raised to the fourth. And again, we'll call this g prime of x. That's number 23. Let's do one more. We'll call this 24. And on 24, we have the integral. And again, let's call this, before I write the integral, we'll call it g of x again. Now we have the integral from 1 to cosine x. And it's going to be 1 minus t squared over 1 plus t to the fourth. And I want the derivative. So g prime of x, you get 1 minus cosine squared x divided by 1 plus cosine to the fourth x. But remember, by the chain rule, we have to multiply by the derivative of cosine x with respect to x. So we have to differentiate that upper limit. Now, for full credit, I expect you to say that 1 minus cosine squared x is sine squared x. So this is sine squared x. Here, let's rewrite that a little better. So we get sine squared x divided by 1 plus cosine to the fourth x. And I'm going to take that answer and multiply by negative sine x. And so therefore, g prime of x is negative sine cubed x divided by 1 plus cosine to the fourth x. And that's a good stopping point for this video. And this is a video from the Exam 4 review. And we looked at problems 18, 19, 20, and then 21, 22, 23, and 24. Thank you.